Hey guys, welcome to your Algebra 2 video on simplifying rational expressions. Playing Abbey Road by the Beatles in the background right now. I don't know if it's going to work because the heat just came on. I'm going to be recording this in fits and starts today. We're going to be doing a couple of slides this morning and then I'll do a couple later on and so on. Okay, so simplifying rational expressions. Rational expression is the quotient of two polynomials. So it'll be an algebraic expression on the top and an algebraic expression on the bottom. It's in simplest form when its numerator and denominator are polynomials that have no common divisor. So you can't simplify it any further. Just like a regular fraction. You're going to look for restrictions on the variable that might cause you to divide by 0. So we will be adding, subtracting, multiplying, and dividing rational expressions today. And we'll also be simplifying ones that don't have any operations to be done between them. So let's get started with simplifying. So we're going to take this expression here and we're going to start off by factoring the denominator. I don't know what I want to do to that numerator yet, but I know I want to factor that denominator. Factors of 8 that add to negative 6 would be negative 2 and negative 4. All right, so now I can think about what I want to do to that numerator, and most likely I'm going to be looking for something I can do to that numerator that's going to give me one of those two binomials you see in the denominator. Please excuse my computer for being so noisy. Okay. So I can see here that negative 6 plus 3x is the same thing as 3x minus 6, and that's the key here. We're going to factor out a 3, and that leaves x minus 2. Whoops. X minus 2. Let's try that again. There we go. And the x minus 2's are going to cancel with each other. So in this expression, you end up with, for an answer, you end up with 3 over x minus 4. And we can say that there is one restriction on the variable. X definitely cannot equal 4. Because that would give you a 0 in the denominator. And that is simplified. Let's try another one. Okay, so this one we have a trinomial on the top and a trinomial on the bottom. So we're going to factor the numerator. So I want factors of negative 4 that add up to negative 3. So factors of negative 4 that add up to negative 3 would be negative 4x and positive 1x. So now I'm going to factor by grouping. Take out a 2x here, leaving x minus 2. You know, again, this year, we're doing a whole lot of factoring. And I know it's a drag, but the more practice you get, the easier it's going to be. And then these problems are cake. Okay, I like cake. Cake's one of my favorite things. All right, so this denominator, factors of 6 that add up to negative 5, are negative 2 and negative 3. And again, you can see, canceling that x minus 2. Now this time you have a numerator that has an expression and a denominator that has an expression, instead of just a number up top like the previous one. But the numerator doesn't cause any sort of restriction situation. We don't have to worry about this. Like this could be 0 and that's fine. But the denominator can't. So once again, we have a restriction. X cannot equal 3. Let's try multiplying two of them. So you can see it's actually two algebraic expressions to be multiplied together. Okay, sorry I had a quick distraction there. So we're going to multiply the two expressions together. I know this looks daunting. All you're going to do is factor these down and do some canceling. And we should have at this point that you're watching the video done some review with fractions. So remember how you can simplify down your fractions. All right, so let's factor the numerator there. So factors of negative 6 that add up to 5. That's going to be 6 and negative 1. So 3x squared plus 6x minus 1x minus 2. Factor out a 3x, leaving x plus 2. Factor out a negative 1, leaving x plus 2. And that numerator is, so coming over here, 3x minus 1 and x plus 2. The denominator, just x minus 5. And we're multiplying, and we see a difference of squares, so x plus 5, x minus 5. I'm going to run out of space. Eee, tight. Okay, and then we got to factor this one. So we want factors of 6 that add up to negative 7. Well, that's got to be negative 6 and negative 1. Negative 6x minus 1x. Take out a 3x again. This time it leaves x minus 2, though. And to get the x minus 2, notice both signs are changing. We're factoring out a negative 1. So, oh, I didn't do that last time. Let me come over here. All right, so that's 3x minus 1 and x minus 2. minus 2. Oh, just barely made it. Okay, so canceling. Now we can cancel top to bottom, but we don't have any common factors top to bottom. Look here and here, no common factors, same thing. But we can cancel here and here because they're diagonal. And we can cancel here and here because they're diagonal. Don't jump the gun, though. You can't do the x plus 2 and the x minus 2. Those don't cancel. You're going to multiply it back together. X plus 2, x plus 5 on the top, and x minus 2 on the bottom. And in some circumstances, you'll leave it like that. In some circumstances, you will multiply it out. So for the benefit of our activity, we're going to leave it like that. But what restriction is there on the variable? X can't equal 2. All right, let's try one where we're dividing, which is kind of a trick question because we'll have discussed in class by now that you don't really divide. You flip and multiply. So let's start by factoring them down. This one's a little bit faster. Factors of negative 15 that add up to positive 2 would be x plus 5, x minus 3, over y, change the variable on you. Sorry, y, not x, y. Y. Okay. Difference of squares, y plus 4, y minus 4. Okay. And then I'm going to change it to multiplication. And I'm going to put that 3y minus 12, except it's going to be 3 times y minus 4. I'm going to put that on the top and the y plus 1 on the bottom. And sadly, we don't get a whole lot of canceling action, but that's okay. That's all right. We can only cancel this and this. So we kept the first one. We factored it, of course. We kept the first one. We switched it to multiplication and flipped the second one over. All right, multiplying it back together, we're going to have y plus 5, y minus 3, and a 3 out front, and y plus 4, y plus 1. Okay, lots of restrictions on our variable here. Start with, that's supposed to be a 4, sorry. Start with the denominator. Y can't equal negative 4, and it can't equal negative 1. But you also have to go back to the beginning of the problem and look at all of the things that were in the denominator throughout the entire problem. We also have that y can't equal, look right here, positive 4, because this was in a denominator. So we can't have positive 4. And we also have, okay, we already had the negative 1, but we also have, if we had gone back to the beginning, this would be a y minus 4 in the denominator. Now, I know that we already got that, but I just wanted to point that out again. So actually, I need to get rid of my comma. And at this point, because you can't erase once you switch tools, I'm going to have to scribble a comma out. Sorry, OCD folks. Here, how about this? We'll do this. Color over it in white. You can pretend it's not there. All right, that's dividing. Now, adding and subtracting gets a little bit more complicated, just like we reviewed with fractions, because you need a common denominator, and that means we need to be able to find least common multiple. I know it's a pain, but it's not going to be that bad, I promise. Start by factoring. So I'm going to factor out a 4, leaving x squared minus 9, and that's 4 times x plus 3, x minus 3. This one here, we're going to factor out a 6, and that's going to leave me x squared plus 6x plus 9. Is that it? Yeah, and that's x plus 3, quantity squared. So 6, and then x plus 3, the quantity squared. So we want the least common multiple. So start by finding the ones that they have in common. Let me underline all the ones they have in common. X plus 3, one of the x plus 3's. The 4 and the 6 both have a 2 as a common factor. Okay, so first let's find the least common multiple of 4 and 6. What's the least common multiple of 4 and 6? Now, if we find least common multiple, I take the bigger number and count up by multiples. So 6, 4 doesn't go into 6. 12, 4 goes into 12. So we have a 12 in our least common multiple. Now we put our common factor one time, and then we put each of the other things they don't have in common. The second expression has another x plus 3, so we need that, and an x minus 3. And this would be the least common multiple of those two expressions. It's long. I know, it's terribly, terribly long. But if you can break it down, figure out what they have in common, and then bring on all the other terms, all the other, factors that you see in each one, then you've got your least common multiple. Let's try one where we have to find the least common multiple, the least common denominator. So an adding example. And this one's much simpler, so don't stress. All right, start with factoring your denominators. This one's x plus 4, x plus 1. Messy. X. Okay, and this one's 3 times x plus 1. So we've got an x plus 1 in common. So our least common multiple here, least common, in this case LCD for least common denominator, not liquid crystal display, but you know. All right, so we have an x plus 1, that's what they have in common. And then we have a 3, and then we have an x plus 4. And so what you're going to do is you're going to multiply for each fraction by the part they don't have on the top and the bottom. So this first one is 1 over x plus 4, x plus 1, right? I'm going to extend my fraction bar out. And this one's 5x over 3 times x plus 1. Now, what don't they have? This bottom one doesn't have the 3. Or the first one, I should say, doesn't have the 3. The second one doesn't have the x plus 4. And you see how I'm multiplying both numerator and denominator? That way, really what I'm multiplying by is 1. All right? Keep the denominator out. You don't want to multiply that together, but you do want to go ahead and multiply your numerators. So here we have 3 plus, and here we have to distribute 5x squared plus 20x. The denominator will stay 3, and then let's just put it in the order x plus 1, x plus 4. And that is simplified. Now you may want to check and see if you can factor the numerator. Let's put it in order. 5x squared plus 20x plus 3. Factors of 15 that add up to 20? Definitely not. They don't exist. So we are done with that problem. And you don't need to multiply the denominator out at all. We do have to find restrictions on the variable, though. What can x not equal this time? Well, it can equal -1, and it can equal -4. Because that would give me 0 in the denominator for each of those two factors. Now, shockingly, I've been able to make it almost all the way through this video without too many interruptions. I think I might actually be able to finish it this morning. How exciting. Now we're going to subtract rational expressions. So let's factor and figure out our LCD. If you'd like to pause it and try it, you're more than welcome. But I'm going to go ahead and jump right in with 2 feet. So this one, if I factor out a 5, I'm going to have z squared minus 25. So that's a difference of squares. So z plus 5, z minus 5. And this one I'm going to have 3 times z plus 5. So my LCD this time, we have what we have in common. We have, let me switch my colors. We have a z plus 5 in common. So we have z plus 5, one part, and then there's a 3. Again, there's always a 3, it seems, in these problems, isn't there? Then there's also a 5, and then there's a z minus 5. So that's my whole least common denominator that I need to make happen here. So remember what we did next. We took the expressions and wrote them with extra long denominators. We already have this 5 and the z plus 5 and the z minus 5. So the only thing the first one needs is the 3. Oh, let me do it in a different color like I did before because that was easier. All right. Then we have subtracting, and that's going to be different here. So that's one place where we have to pay close attention. We have the 3 and z plus 5. We need the z minus 5 and the 5. The z minus 5 and the 5. Let's multiply that out. So this will be 21z. Got that part, no problem. This is going to be 20. Let's multiply these first, 20, and then distribute. So 20z minus 20 times 5, 100. So we're going to have 21z for the first one. Minus, and then I'm going to put this numerator in parentheses because it does make a difference, absolutely, because I'm subtracting both of the terms, and the sign on that -100, that minus 100, that's going to switch. And then we've got our whole denominator underneath it, so 5 times 3, so 15, z plus 5, z minus 5. I know I made that a little uneven, but that's okay because we still have to simplify it one more time. 21z minus 20z is z. Minus a minus 100 is plus 100. So that's where we're going to make mistakes on this stuff, guys, is right there at the end with the subtracting ones, where we end up with a sign switch if we're not paying attention. All right, last thing we're going to do is complex fractions. Hideous looking, but not that hard. Don't panic. It's okay. Look at the two fractions you see within the fraction. That's why it's called a complex fraction. Haha, complex, because it's fraction inside a fraction. What's the common denominator of x and y? That's right, it's xy. So what we're going to do in this is we're going to multiply every single term, everything in this entire problem by that common denominator. So I want to switch colors. I've been using red and blue the whole time. Let's use green. LCD, x times y, or xy. So 1 over x plus 3, 5 over y plus 4. So we're going to multiply. Let me switch to another color again. How about purple? Except I don't like that color, purple. There we go. That's a better color, purple. All right, so we're going to do this times xy, and this times xy, and this times xy, and this times xy. And what we're really doing is we're taking that whole fraction and multiplying by xy over xy, and it's just being distributed. You see it? Okay, so we're not changing the expression at all. Well, what do I get? xy times 1 over x. The x's are going to cancel. I'm going to get y. Plus 3 times xy is 3xy. Xy times 5 over y. The y's are going to cancel. We get 5x plus 4xy. Guess what? That's it. That's all you have to do. There's nothing else that you have to do in this in order to get this to work. There is one restriction on the variable, though. No, excuse me, 2 restrictions on the variables. X can't equal something and y can't equal something. Can you figure out what it is? Well, in the end result, if this x and this x were both equal to 0, then the denominator would equal 0, and that won't work. So it's definitely 0 for x. In the beginning situation, an x of 0 or a y of 0 would have been a problem. So y also can't equal 0. I thoroughly enjoyed making this video this morning, especially because I got the whole thing done before school even started. So we're going to finish out, let's see. Oh no, there's still 5 whole minutes of this song left. So we're going to say goodbye to the Beatles. And I will say, I'll see you guys in class.